Good afternoon, students. Today we will continue with the chapter on atomic structure. Our day's topic is periodic table. To understand what is periodic table, we need to go back to the term atomic number. What is atomic number? It is the number of protons present in the nucleus of an atom. This will be equal to number of electrons if the atom is neutral. Protons are positively charged subatomic particles and electrons are negatively charged subatomic particles. Arranging the elements according to the increasing order of atomic number. Increasing means from the lower to the higher. Arranging the elements in the increasing of order of atomic number is what the periodic table is about. Hence, you will find that elements are arranged in such a way that hydrogen has atomic number 1, helium has atomic number 2, lithium has atomic number 3, beryllium has atomic number 4, boron has atomic number 5, carbon has atomic number 6, nitrogen has atomic number 7, oxygen has 8, fluorine has 9 and neon has 10. Sodium has 11, magnesium has 12, aluminium has 13, silicon has 14, phosphorus has 15, sulfur has 16, chlorine has 17, argon has 18, potassium has 19 and calcium has 20. You have 20 elements which you have to learn according to the increasing order of their atomic number. There are many elements. You have first 20 in your syllabus. In a periodic table you will find there are 7 horizontal rows. These horizontal rows are called as the periods. They are 7 in number, 7 horizontal rows. Each horizontal row represents the number of shells present around the nucleus of an atom. So in an atom, if this is the nucleus and these are the protons, the shell in which the electrons are present, according to the number of shells that are present, you will find the elements are placed in that particular period number. The vertical rows are called as the vertical columns are called as the groups, and these are 18 in number. These groups are according to the number of electrons present in the outermost shell of an atom of an element. So the outermost shell is also referred to as the valence shell, and the number of electrons present on the outermost shell, they are called as the valence electrons. So according to the number of electrons present on the outermost shell, elements are placed in that particular group number. If you take the element hydrogen, you will find hydrogen has atomic number 1. That means if you consider this atom, you will find hydrogen has atomic number 1. So proton is 1 and electron is 1. So how many electron it is having in the outermost shell or valence shell? It is 1. So it is placed under group 1. Okay. This is a group, it is placed under group 1. How many shells does it have around the atom? It has only 1 shell. Total number of electron in hydrogen is 1 because each shell has a fixed quantity of holding electron. The first shell can hold maximum of 2 electrons. So if it has only 1, there is no question of a second shell being formed. So 1 electron, that means it is only in the first shell. So according to the number of shell, we have the period number. So it is placed in period 1. It has 1 electron, so placed under group 1. It has 1 shell around the nucleus, so it has period 1. Let us take another element. Let's take oxygen. So oxygen, if its atomic number is 8, that means number of protons and number of electrons will be 8. So if I try to draw this in the form of electron, arrange the electrons in this oxygen atom, you will find that oxygen has 8 protons and 8 electrons, and 8 electrons means what is the capacity, maximum capacity of the first shell? Shell number 1 can hold maximum of 2 electrons. So if I draw 1 electron here and 1 electron here, we are left with how many? Total is 8. 2 I have placed here. So it is 8 minus 2, we are left with 6 electrons. To accommodate these 6 electrons, I will draw the second shell and place it 1, 2, 3, 4, 5 and 6. So 2 in the first shell and 6 more on the second shell. So we are getting the total of 8. That means how many shells are involved in case of oxygen atom? 2 shells. So you will find it is placed in the second period because the number of shells denotes the period number of an element, and it has 6 electrons in its outermost or the valence shell. So it is placed in group number 6. It is seen that all elements having the same number of electrons in the valence shell will be having the same chemical properties as well. A quick recap of how to write the symbols of a compound. From the symbols, how to write the formula of a compound. Let us find out the definition of certain terms. What do we mean by atomicity? Atomicity is the number of atoms required to form one molecule of an element. Number of atoms required to form one molecule of an element. Most of the metals, the metalloids and noble gases, they have atomicity 1. That means one atom of this metals, metalloids and noble gases, one atom can behave as one molecule. Elements which has atomicity 2, you will find most of the elementary gases. You can consider any gases, any gas like oxygen. 1 atom plus 1 atom, we get formula of the oxygen gas, that is O2. If you consider hydrogen, 1 atom of hydrogen plus 1 atom of hydrogen, we get the gas hydrogen, H2. So for these elementary gases, you will find atomicity is 2. If we take the gas ozone, ozone you will find requires 3 atoms of oxygen to form this gas ozone with a formula of O3. That means atomicity of ozone is 3. More than that, we will consider that atomicity is more than 3. So we will call them as the polyatomic elements. Like phosphorus has 4, sulfur has 8, etc. Next we come to the term radicals. What are radicals? When an atom of an element or group of atoms of different elements behave as a single unit and carries a charge on itself, we call them as radicals. One atom of an element or a group of atoms of different elements but behaving as a single unit and carrying a charge. Accordingly, you will find we can divide radicals into 2 types. We can have acid radicals and we can have acidic radicals and basic radicals, or we can call simply as acid radicals and the basic radicals. You will find these acid radicals are negatively charged radicals. They are negative. You know, the sign indicates negative. These are negatively charged radicals where these are ions of nonmetals or group of atoms of nonmetals behaving as a single unit and carrying a charge. Like if you consider oxygen, the radical oxygen will be carrying a charge of 2 minus. If you consider the radical of chlorine, chloride radical carries a charge of 1 minus. But if you consider group of atoms of nonmetals behaving as a single unit, we can take carbon, we can take oxygen. This radical CO3 carries a total charge on itself which is 2 minus. Okay, this satisfies the first definition. The second definition, so acid radicals are also called as anions because they are negatively charged particles. The basic radicals are positive radicals. They are also called as the cations. These are atoms of metal or group of atoms of nonmetals carrying a positive charge on itself. Like if you consider the metal, say sodium, it has valency 1. If you consider calcium, it has valency 2. Group of atoms of metals or group of atoms of non-metals carrying a positive charge. We have only one positive radical in our syllabus where nitrogen and hydrogen with NH4 carries the charge 1 plus on itself. Usually these are of metals, but here you will find non-metallic atoms behaving as a single unit and carrying a charge on itself, positive charge on itself, so it comes under the cations. Okay. We need to learn the symbols and the valency and the radicals, how to write them in order to write the formula of a compound correctly. So, to write the formula of a compound, definitely, and once again I repeat, it's very important, students, that you learn the symbols and their valencies. Okay, here you'll find, if I take, say a simple one, I am taking sodium. Sodium is a monovalent element, that is, it has valency 1 plus. Being a metal, all metals have positive valency, and I am combining it with, say, the chloride radical, which has valency 1 minus. It is an acid radical, or we can say it is an anion. We have learned that in order to write the formula of a compound, we need to interchange or crisscross the valency. Here, both being 1, even if you change, this becomes 1 and this becomes 1, so there is not much change. If you are getting 1, if you do not write the number, it also means 1 atom only. So the formula of this compound will be NaCl. Here I have written separately with a space. When you are writing the formula, it should be written together. The second thing you have to keep in mind is sodium. Its name is derived from, or the symbol is derived from its Latin word, which is natrium. So what do we find? That N is capital and A is small. When two alphabets are there, the second alphabet will be small, like for chlorine, C is capital and L is small. If you consider another set where we are taking calcium. Calcium is a metal with valency 2. Being a metal, it has positive valency. We are taking a radical now, which is made up of atoms of two nonmetals, oxygen and hydrogen. Together it forms a hydroxide radical, and as a unit it behaves and carries a charge which is 1 minus. So how to form the formula of a compound? Write the formula of a compound where we have calcium and hydroxide radicals. So what do we do? By this crisscross method or by interchanging, you'll find 2 of calcium comes here. We do not consider the charges, we simply ignore the charges, but we have to write them because that is the valency of each element. and 1 from hydroxide comes down here. So what do we get? How do we write the formula then? Ca is 1. We need not write this number. We can ignore Ca. OH, I said you have to write it close enough, and we have 2. Now students, if I write 2 here, you will find 2 means H2, but here we are not having oxygen and hydrogen separately. They are together behaving as a radical. So what do I do? This 2 is for this entire one. So I put this within bracket and then I write 2. So 2 atoms of hydroxide radical. And this is the formula of the compound when calcium combines with hydroxide radical. One more we can do with a different combination. If you take aluminium. Aluminium is an element with valency 3. Let's combine it with another known one, that is Cl we take, which is having valency 1 minus. So if you interchange, we are getting 1 here, 3 comes here. So formula of the compound will be Al. 1 I need not write. AlCl is 3. Now this being 2 letters, why we are not putting it under bracket? Because Cl together is representing only the chloride radical. It is not made up of atoms of different elements. It is of the element chlorine. So we need not put it under bracket. Okay. So you have seen 3 different cases how we can write the formula of the compound. So for this, what we need to know? We need to know the symbols correctly, and obviously initially valencies may be given, but you have to memorize the valency and learn, because later on when we will do the equations, then definitely the valencies will not be provided to you. Okay, students, learn the chart. It's not easy. If you just follow it methodically, it will be very simple, and I hope you all do well. Thank you, students. Stay well.